So you've given this question a good try. Let's see how you did. So let's determine the main variables. That is, how many ounces of each type of food go into our mix is the main question here. So let X equal the number of ounces of food A and Y equal the number of ounces of food B. And of course, those can be switched as long as you document it properly. Now we're told about the nutrients within each food. So let's use that to make some inequalities. For fat, we see food A has 8 grams and food B has 12 grams. And our resulting mix should have equal or more than 24 grams. So our inequality, 8x for the amount of fat in food A plus 12y for the amount of fat in food B, and that has to be equal or greater than 24. Switching to carbs, food A has 12 grams and food B has 12 grams. So 12x plus 12y has to be equal or greater than 36. There's our second inequality. We look at protein. Food A has 2 grams and food B has 1 gram. So our resulting inequality would be 2x plus 1y has to be equal or greater than 4. And we look back at our question, we see that they are to have equal or less than 5 ounces daily. So x plus y, the total amount of food, has to be equal or less than 5. Now we do have a couple of extra constraints, that is x equal or greater than 0 and y equal or greater than 0, as we can't have less than 0 of either type of food. And back to our question, we notice that we're trying to minimize our costs. So our objective function is a formula for cost. And if food A is 20 cents per ounce and food B is 30 cents per ounce, our cost equation would be, well, we could write it as C equals 0.2x, that is the cost in dollars of food A, plus 0.3y, that is the cost in dollars of food B. And we'll save this equation for our final analysis. And so we're ready to take this system of inequalities and graph it. So let's go to Desmos, and we enter all of our inequalities, and we take a look at a graph. And this here is our allowable region, a little different looking than some of the others. So let's label and identify our vertices. And in this case, we have 5 of them: A, B, C, D, and E. And reading the locations from our graph for each of these points, A is found at 0,4. That is only 4 ounces of food B. B represents 5 ounces of food B, also within the constraints. C is found at X is 5 and Y is 0. That is only 5 ounces of food A. D represents 3 ounces of food A, also within these constraints. And finally, E mixes 1 ounce of food A with 2 ounces of food B. Taking our vertices and using our cost equation from before, let's determine the cost at each one of these points. Plugging in the numbers, we get $1.20 at point A, $1.50 at point B, $1 at point C, 60 cents at point D, and 80 cents at point E. So, we can state that Lisa can minimize the costs while still keeping the rabbits healthy by feeding them 3 ounces of food A each day.